Welcome to the VETRO FiberMap Customer Enablement Webinar Series. And thank you all for making time from your busy schedules to join us for a short session, training session. My name is Will Mitchell. I'm the VETRO co-founder and the CEO. We're really excited about the continued growth in our customer base and the ongoing advancements in our platform. We're happy that you're using it and hopefully successfully so. We want to do everything we can to enable you to get the most value out of the platform. And that's what spawned these customer enablement webinar series sessions. This is the second in our new series of webinars. This session will focus on circuits. Fiber paths and circuits are critical to the fiber mapping and management workflows that you're up against every day. They reflect the network and how things are connected. And in the context of mapping systems, our FiberManager tools and the circuit management and circuit definitions really set VETRO apart from your typical desktop GIS or Google Earth, or certainly from CAD drawings. We hope you're using circuits or will begin using the circuit-related features. This session will give you an introduction and cover how we approach their creation, editing, modeling, and management. Just as an FYI for this series, we are recording the sessions. We'll make them available in the support section of our new website that is actually set to go live this month, very soon. Questions can be submitted via the chat window during the webinar or in the scheduled Q&A section at the end. We'll do our best to respond on the fly, either by chat or to the group during the Q&A. If you do submit a question that we can't get to, we'll certainly follow up directly. With that intro, I would like to turn this over to our customer success point person, Stephen Marchessault, who will run you through our circuit features.
Thank you, Will. Hello, everyone. I'm Stephen Marchessault, Customer Success Specialist here at VETRO FiberMap. Thank you for joining us today for our second installment. Very glad to be here with you all. Today, like Will said, we'll be talking about circuits in VETRO FiberMap. The webinar will be recorded, and before that support site goes live, you will receive an email that will come along later today with a link to view or download this recording if you'd like to see it before then. Also, an additional point before we get started, Cecilia from our marketing team has asked me to remind everyone to fill out our customer feedback survey. If you have not done so yet, it was sent out a week ago. This feedback is very valuable to us, and as a thank you to anyone who completes the survey, they will be entered into a drawing for a $100 Amazon gift card. So please let us know if you did not receive the email and would like to fill out the survey. Now for a quick overview of the slides of what we'll be covering in today's session and demo, and then we'll jump right into that demo. We will be talking about circuits, what they are, how they're represented in VETRO FiberMap, and how they are created. So to start off, circuits are the fiber pathways that connect service locations to your network. They're represented as an A to Z pathway. So the A location is typically a CO or central office, a point of presence or POP, or the head end. And the Z location is most often going to be represented as a service location. And then going from A to Z, a single fiber pathway unites the whole circuit across network points, and all of these are captured in the circuit information. So we will get into more details on all of this. So we'll be looking at how we open the already established circuits in VETRO FiberMap. So for an existing circuit, there are mainly two ways to view the circuits. You can open a cable or point and view in the attributes for that point or cable any circuits that are passing through that point or cable. If you expand the Show Circuits menu in the attributes. You can also search for circuits in the search bar. So you begin typing and you can view type ahead suggestions for those IDs. So those are the two main ways to access circuits. Now there are a variety of ways that we keep track of, interact with, and extract information about the circuits in VETRO. And some of these are the Spliced Reports, which shows us all the cables that are spliced at a certain point. And if any of the fibers contained within that cable are part of a circuit, we will see that information listed, like in the picture on the left there. The circuit report also contains information about the circuit, and we'll be getting into more detail about what is included in that circuit report. Also in FiberManager, which we'll be talking about today, and the Splice Diagram, which we'll be talking about today, we have ways of representing fibers that are part of a circuit. So in the case of the FiberManager, it's the blue background with the lightning icon. In the case of the Splice Diagram, it's those blue strands that you see in that diagram to the right. So again, this is a quick overview. We'll be getting into all of this. So going back to our last webinar, we talked a bit about validating and building networks. So I wanted to review a couple of points that will become important here for managing the status of your strands and how that gives rise to circuits. So the build needs to be performed before FiberManager can be used and before you can create a circuit or reserve strands. So this is a very important step to go back to and remember that it needs to be done. And on top of that, if you want to add a point to your circuit at any point, you can insert a point onto a cable, run the build, and it will integrate that point into the circuit. So we're going to get into the demo portion here after 2 more slides. So we want to start the demo with some of the tools that we use for splicing, tracing, and defining the circuits. So we have the Splice Diagram and the FiberManager. So to start with, Splice Diagram is a place where we manage splicing for all cables at a given point, 2 cables at a time. So you have drop-down menus at the top where you can alternate between cables, and you can manage the splices, and there are a variety of different methods and tools integrated into that, and we'll go over that. And also FiberManager is where we manage fiber pathways for all cables between 2 given points, A to Z. So this will be the first segment that we jump right into. So I'm going to pause my screen really quick here while we switch over to VETRO FiberMap. All right, here we are. So here we have a small network built in a town in Iowa. I have already run the build process to complete the fiber tracing to automate the creation of pass-throughs and splice points following the steps from last time. So just to have a look at this network that we've created here, we have a partner backbone that's passing through, and then we've tied into that. In the Northwest, we have our CO, and then we have a series of cabinets, FATs, joining our laterals, and we end up at splice closures, which pass through drops and terminate at our service locations. Kind of a quintessential network design in this town here. So whenever we're ready to design or edit in VETRO FiberMap, we need to first enable the global editing mode. And then we need to designate the plan that we intend to edit within with this pencil icon. So that's an important first step. So to look at the FiberManager, to start with the splice diagram, we'll jump right into an example of a fiber access terminal in the middle of one of these cables. So if we open any point and we scroll down the attributes, here we can open our splice diagram. So here we see 2 things. We have our lateral coming in from the north and our lateral going south, and it's represented in blue here in the splice diagram and represented in blue on the map. And downstream, we have the pink, and that's represented on the map as well. We see a couple of different things going on with these fibers here, right? So we have gray strands, which are reserved. We have these dotted lines, which are pass-throughs, and we have these connected available fibers that are dark. We also see blue here, and this represents our circuit. So the physical aspect is represented by the shape of the line, or by the line type rather, the dotted or the connected. If it was cut, so I can jump into another example here in the splice closure and have a look at the splice diagram here. And so we will take a look at the lateral coming in from the south and this backbone going to the north upstream. We have cut cables, and we have reserved cables, and we have our circuits here. So one of the advantages of seeing blue and gray circuits is we've reserved strands, in the case of the gray, or we've created circuits in the case of the blue. And when we're upstream, we can keep track of what's going on downstream. And that can be a major challenge when you're trying to figure out which buffer is available for cutting or not, for example. So now we'll have a look at our fiber access terminal again and look at some of the ways that we represent equipment in the splice diagram. So if you want to interact with the strands in your splice diagram, these can be clicked, and you can right click and select cut. You can select an entire buffer at a time and cut, or you can select multiple by holding shift click. Go back to that spot I was in here. Shift and click and right click to cut. Now from here, we can grab one of these strands and we can shift, click, drag to connect. We can drag multiple, or we can even select multiple, right click, and splice all. Likewise, you can cut and connect entire buffers at a time. So I'm going to just cut these strands again and attach some equipment at this FAT. So we have the ability to attach various equipment types, and one of those is a splitter. And we can add a splitter to our FAT. We'll indicate that it's a 1x4. And to show how we represent cascading splitters in case of a GPON or home run setup, we can attach another splitter like this and add whatever configuration here. And now when we head back to the attributes for our FAT and open the splice diagram, first I need to save. I'll save these equipment types, open the FAT, open the splice diagram. Now I see we have two pieces of equipment that are currently unattached. So for single pieces of equipment in the splice diagram, we can right click on the upstream side and attach equipment this way. So now I can grab this cable and click and drag. Here's my equipment selection. Here are my available ports. I'll say port 2 and connect. And in this way, I can connect multiple fibers. We'll say 3 and so on. If we want to begin to look at multiple pieces of equipment, we have this other menu, show equipment connections. So from here, we see our splitters listed on the left. So this is the splitter I just configured. On the input side, we have our lateral, and here are the two output ports, which are the two lateral strands, 50 and 51, going south. If we wanted to set up cascading splitters, one of these ports here, we'll say port 1, I can choose between cables or equipment. So now I can attach the other splitter to port 1X, which is the input. So now the splitter has been attached. I can click this link here or over here to go to the splitter. And now we see the input into this splitter is the output, port 1 from the other splitter. And then from here, we can now attach cables going north or south. So I'm going to remove these connections for now and go back to the splice diagram and remove this equipment here. And we will just restore these to what they were in this network, which was the pass-through, right? So now that we understand the primary method for opening the splices and equipment in a point, we will take a look at a very important tool in VETRO FiberMap, which is the FiberManager. Now, FiberManager is going to allow us to take a look at the cables and the fibers contained within across an A to Z pathway. So FiberManager is this tool, this round icon here on the left-hand side, and we select this here. And one of the first things that we do when we select FiberManager is we elect to select an A location. So I want our A location to be our CO. So I'll click right on CO here, and we see that it has auto-populated the address that was entered for that CO. And now I'm interested in seeing what's going on between the CO and this service location at the end of the drop here. So in the left panel here, so we see this is the Z location, the address for that service location. I'll zoom out a little bit so we can see kind of a bigger context of what we're viewing. In the left panel, we have the ID of our CO. This is the cable that it's passing over. From this point, we actually have multiple cables going in different directions. We have the cables going to the trunk and then to the network, so we can alternate between those cables here. But we currently have the one we want selected, which is the backbone to the network. Then we have our cabinet to our splice closure to the service location. And then these are the cables and the links connecting those. So what we see here in the lower panel is the same schematic, the network hops represented left to right, but we see no fiber paths found. So what we need to do is troubleshoot what's going on with our connection. And there are a few different ways we can do this. We can backtrack through the splice diagrams for each of our locations. So if we select any of the points on the left-hand side, this will open the splice diagram for that point. And now we can see what's going on with these cables, what's available, what's not available. If we see a T, it represents a connection to a different cable, and so on. Another way that we can troubleshoot is if we move our Z location backwards. So I'll click and drag back to the splice closure here. And so now we see there are a couple of different things going on here. These are the fiber pathways from our CO all the way to this splice closure. So I'm zooming in a little more to make sure I get the splice closure. There we go. So what we see here, when we go from the CO to the cabinet over this backbone cable, we're on fiber 1. Here we have a black dot, which represents equipment in FiberManager. So we have a patch panel in our CO. So strand 1 is connecting to port 1 of 288. And then when we get to the cabinet, we splice into fiber 1 again. And then we arrive at our splice closure. So we know now that we have pathways that go to the splice closure. So if we move this Z location back to here, we just need to see what's going on from the splice closure to our service location. So I'll open the splice diagram on the left-hand side for the splice closure. And again, we see the cyan cable is our backbone going north. And here, this pink cable is our drop, which is currently not connected. So I want to click and drag to establish a connection. And in doing so, I have now created a pathway from CO all the way to the service location. We see we start out on fiber 2 until we get to that splice closure. We attach to fiber 1 and then the service location here. Now, this is a simple example. I would like to now take FiberManager over to more of a complex example. We can drag our Z location, or I'll restart the trace again here with the CO here. And now we'll head over to this street here, this splice closure. So this shows us a little more of a complex view of what's going on as we move along through our network. The same schematic applies, and these are all of the pathways that are now available. So if we move our Z location out to this service location, we see we have a pathway that goes all the way to this service location. And of interest here is that we are connected to the lateral at the splice closure. We're connected to a splitter here. So when we move the Z location backwards, we see that we have duplicate pathways here that are represented 4 times, right? All the way until we get to this splice closure. So if we look at what's going on with this equipment here, this is port 1, this is port 2, this is port 3. So by connecting to a splitter, we've essentially created the opportunity for 4 individual pathways. So these are now all represented that way in this, this schematic in FiberManager. So I'm going to pause this here. I'll leave that for a moment. I want to jump back to our slides and cover the next topic, which will be circuit creation. Open that here. Bear with me. Here we are. All right, so creating circuits. We have 2 major methods available to us when we're creating circuits. The first will be from that screen that we're looking at now, FiberManager. We can elect to manually select the pathway from our A location to our Z location and set it aside as reserved, or we can set it aside as a circuit. And this typically arises in a situation where you're designing an as-built network, and as of today, you know this customer is connected. You're ready to form that connection. The other method is this tool called Quick Connect. So in the case of Quick Connect, you'll create a new service location, and it will automate the creation of a drop back to the nearest reserved fiber path. The other way that you can use Quick Connect is if you already have a drop established and you click on that service location, then it will quickly create a circuit the whole way back to the CO for you. So these are the two different ways that we can do this. The second situation arises in a situation where, say, after you built your network or designed your network, down the road, a customer contacts you and initiates a connection. So this is a way to quickly accommodate that. So I'll pause my screen again here and jump back into our demo. So here we are. We'll have a look at this service location here. This is the one that has the fiber pathway established the entire way. And this is the splice closure that's just before it. So let's say that we're going to set aside ports 2 and 3 as reserved at the splice closure. But before I do that, I'll do that in a different example. We'll just jump down to this service location here. First, we'll establish the circuit to this service location. So if I check this box here, we can set this to be a circuit. So here we have the opportunity to enter our customer's name. We'll say it's the Smiths. We have a circuit ID, which is system generated. It automatically iterates. And this can be set as a custom value if you have a way of managing how you want that naming convention to be laid out. But it's helpful to have unique IDs rather than duplicates, especially when you're searching later on. So we have entered this information, and now we hit save. And so now the circuit has been established. So here we see that blue background, the lightning bolt icon, and so on. So now, if I jump back into this example in the north here, we'll grab the FiberManager and create a trace to this splice closure. And I want to see if I can reserve this strand here, say, provided there are no upstream or downstream connections. And we'll select that here and edit and set reserve. So now this has been set aside with the bookmark icon and the gray background. So here's the situation where the customer calls in and says, okay, I am ready to connect. I am at 542 North Main Street and I'm ready to form a connection. So it's typically helpful to switch to the base maps, the Google satellite view, so that we can see rooftops and we can figure out exactly where we want to represent the connection, where the equipment is connecting to that home, the ONT or the FTP. So I'll grab the point here, grab a service location, and we'll say that we're connecting to this corner of the house here. I can enter the street address. So this is going to be 542 North Main Street in Walcott, Iowa. Here's the type ahead suggestion for us. And this is the Jones address, and save. So here is this service location represented on the map. And so now I can use the Quick Connect tool to click on this home. And the first thing it will ask me is, am I adding equipment to the service location? An ONT, an FTP, how many ports, so on. And then next. And then the system will automatically draw a drop to the nearest valid network point that contains a reserved pathway. So in this case, I had a reserved pathway at the FAT here. And so now I have the option to edit this, say they're both proceeding through this pole before crossing the street, and then next, and then save. And then in the final step, it will present me with my options. Here are all of the reserved pathways to that point that are currently available. So here's the one that I just set aside, and we'll save that. And Jones, and save. Circuit has been saved successfully. So now we've created circuits. We want to work with them and view information about them. So this comes into the question of how do I even access information about my circuits? So you may have noticed when I entered the circuits, the automatically created circuit ID was VETRO hyphen and then a series of numbers. So I can begin to type here, and it gives me some type ahead suggestions, so I can jump to my circuits that way. I can click on any point that contains a circuit, including the terminating points themselves, like the service location or the cables. And we'll go into the information panel for that service location. And if we scroll down in the attributes here, we have a listing of all circuits that are connected. But I'm interested in a circuit that passes through this FAT down here. So here we have a midspan point, and we see all circuits that are passing through here. So the one that I'm interested in is circuit 32. So now here is the trace of our circuit. Here are the details about that circuit. The A location to the Z location. Here's our trace. And now from here, we scroll down in the attributes beyond the circuit length. Here's the calculated length, which includes all of the cable lengths, the helix factor, the sag factor, any premise lengths, slack loops, everything is calculated and added into this here. And then here is one of the most important reporting tools of the circuit, which is the circuit report. So if I click on this link here, it will create this PDF, which is generated for this single circuit. And it can be generated in batch for the entire project or plan, and I'll show you where we can do that. But for now, here's the one report for this one circuit. So this tells us everything that's going on with this circuit. What's its ID? What's the customer name? If we entered in the loss or the OTDR length values, they'd be captured here. Here's our A location information, our Z location. Here's the same schematic that we were seeing, similar to what we were seeing in FiberManager. Here are all of the points, the cables, the fibers that are involved. Any equipment connections are represented here with the equipment ID, the port number, and so on. And then all of this is followed by a map showing that. So a very useful tool for isolating what's going on with this circuit, what is all the information, all the context that I need for this fiber pathway. We also capture this information, like I said, in a batch output. So if we open the dashboard in the user menu here and select the report section, we can expand circuit report. And here is where we can download a zip folder containing all of the PDFs for all circuits in the entire project. We can also download this tabular CSV file, which is the circuit inventory tabular CSV. So I have one right here. Oh, here it is, it just downloaded. And we'll open this up. So this output shows us the ID, circuit ID, the customer name, and it shows us the A location port, address, shows us the Z-1 location, which is the point before our service location. And so in this network, it was the splice closures, the FATs in some cases. And then finally, it shows us the service location, which is the Z location, its address, the loss, the length. And then here's the pathway, which shows us the IDs of all the points that are represented. So this output gives you kind of a text table that is a lot easier to work with if you would prefer to have a table of data rather than the PDF format. So jumping back into our instance here, looking at the circuit report, we have the trace, and then we also have this other tab, OTDR. So within this tab, we can save values that we might have obtained in the field if we determined loss information. If we ran an OTDR trace and we wanted to enter that here, You can also upload PDFs containing any information there. So the other tool that exists here is the line break tool. So if you have one of these OTDR, the optical time domain reflectometer tools, where you can go out and find a line break, then you can use this tool to help you calculate exactly where that break has occurred and who has been affected. So let's say a hypothetical scenario, customer Adams called in from VETRO circuit 14, and they said that their service is currently down. And so they're over in this neighborhood here on Century Street. And we know that the nearest tie-in location where we can use our OTDR tool is this FAT here on the corner of North Downey and East James. So I'll open this point here and navigate to that circuit, which was, let's say 22. And here's the trace. And then jumping into the OTDR tab here, the first thing that we do is we choose a starting point for the trace, which is this FAT. Now we indicate a direction of the trace. And so now that has been indicated as downstream. And so now we enter a distance, the reading that we get back from this tool. We don't know where the break has occurred, but the tool is telling us that it's 385 feet downstream, and then calculate. So this creates a breakage report. So now if we zoom in here, we see this point has been designated where the break has occurred. So we can create this report. And here we see this service location 570 in red is the customer that called in today. And the rest of these locations are potential outages because they are downstream from the break that we found. So we can now, from this point, download and output this affected service location CSV, which shows us all of these addresses, the service location ID, and the account names associated with those, and then we can contact the customers as needed. All right, so that brings us to the end of the demo portion of this webinar. Jump back into the slides here, and just a couple of helpful hints and reminders. When you're making changes to existing circuit splices in a given point, an alternate fiber pathway from A to Z needs to exist. So if you have a circuit established and you would like to resplice, say, through an FAT, you're on strand 2 to 3, and you would now like to splice from 2 to 4. The one key in order to do that is that across that entire pathway, A to Z, 4 is connecting the entire way. Whatever strands you're relighting have to have an available pathway the whole way, and that is the information that you see within FiberManager. If you're doing a trace and you see this error cannot generate the circuit trace because of no connected path or available fiber along the possible path, one of the first things that you need to do is run the build. This was something that we covered last time. This creates the tracing and does the splicing behind the scenes and enables you to do the fiber trace. Then after that, zoom in on your A to Z points, make sure that they are over the points that you want them to be on. And lastly, we can't do a FiberManager trace if you have coincident points. So this is something that is not allowed or recommended in VETRO FiberMap. If you have a need, we have ways to attach equipment and nest equipment types within one another, but this is something else to look out for. Another helpful hint to reiterate this point, run the build process before you try to use FiberManager, before you try to create circuits or reserve fiber pathways. And for more information on that, you can learn about draw, validate, and build in our last webinar. Let us know if you want a recording of this. And lastly, a point can be drawn into a cable containing a circuit using the build process. After the build is complete, the point will become a part of the circuit. So that concludes all of the regularly scheduled content and discussion for today. Be on the lookout for future invites to future user enablement sessions. And just a reminder, some contact information. to get in touch with our technical support team Monday through Friday, 8 a.m. to 5 p.m. Eastern Time via phone or email if you have questions about anything. For general information, including sales inquiries, please get in touch with our sales team. They can talk to you about setting up a demo, and they're very helpful. So here's our contact information. So now we want to jump into a Q&A. If we have any questions, points set aside that we want to go over. So we'll jump right in. We have 3 of them. So this was something that came in. Someone asked, can I connect a splitter to a patch panel as in home run architecture? Now, that is absolutely possible. We covered multiple equipment connections in the attributes of the FAT earlier. Say you had a patch panel at your CO and you wanted to set up a home run architecture through a splitter that originates from the patch panel through the splitter. You would simply attach both the patch panel and the splitter to that CO, and you would connect the input to the splitter to one of the output ports of the patch panel. And that's how you would represent that. Another question, can circuits be shared or integrated with an OSS provisioning system? This would be possible using the circuit report in the tabular CSV output, that the text example that I showed you. So you could integrate that table of information into your OSS. You could manipulate the data however you needed to. It's not locked like it would be in the PDF.
Stephen, this is Will. I want to comment on this one too. The VETRO platform is built, just to remind folks, atop APIs for programming and integration. There is work afoot to develop and publish more APIs that relate to circuit and OSS integrations. We have some customers who are using this in different ways, and it's something that will be heavily emphasized in our 2019 development.
Is there another question?
I believe there might be.
Do you have it on your side?
Let's see. Another question was, can I modify an existing circuit or existing circuits?
Yes, it is possible. So the fiber strands can be rerouted at a point if there are fiber pathways available from the A location all the way to the Z location. You can build points into the circuit. If you would like to delete or any points from the circuit, then it becomes necessary to roll back the circuits first and then make changes to your underlying drawing and architecture so that you can then build the circuit on top of that. So the first step is drawing in your design. So it would be necessary to roll back to the drawing phase if you want to make major network changes to your cables and so on.
Thanks, Stephen. We have a question. Can an OLT or switch be added as equipment?
Yes, definitely. We have a variety of equipment types, some of which we didn't see today. We support FTPs, ONTs, OLTs, switches, which would be represented if it's one-to-many as a splitter, or we have one-to-one representations in the case of multi-ports or patch panels. But we have a lot of flexibility around that. And if you have any specific requests, you can certainly reach out to us, and we're happy to discuss how we could model equipment for you.
Very good. Can you roll back one slide? I think we have a link. No, not showing. I was just asked to remind folks about our customer feedback survey one more time. We will send the hyperlink out to webinar attendees post-webinar, along with the link to the webinar, in case you'd like to take that survey, which will close on Friday this week.
Here it is.
Oh, there it is. All right, it's hard to rattle off a URL on the screen here, but it's at surveymonkey.com/r/VETRO 121818. Okay. Don't see any more questions in the panel chat room here. We'd like to thank you again for making the time. We try to keep these as short as we can and try to keep our features as simple as we can, so they're easy to use and they're even likable, even in the kind of complex engineering space that you're working in. Hopefully the circuit presentation was informative, and maybe you saw some things you hadn't seen before. There's a lot buried in the workflows and the interface, and our circuit feature set is only going to expand and improve over time. Please reach out to our support team. They are very responsive, eager to help. By the same token, our product management team and our leadership team, Sean Myers as product owner and COO, always wants to hear from customers about how they're using the tool and how we can make it better for you. So, and that includes a very heavy emphasis on fiber paths, FiberManager, splicing, and circuits. So I think that will do it for this session. Thank you again. Happy New Year to everybody. We will send out an invitation to the next series, next session in the series shortly, and we hope you can continue to attend. We will also make the video available for your viewing and review pleasure, or for sharing with colleagues who couldn't make it. Thank you very much.
Thank you.